Okay, on this lesson, we're going to be reviewing factoring polynomials. So we've gone over this before. So today we're going to be looking at GCF, quadratic form, which is a trinomial, and then grouping. So let's focus on GCF first. So the greatest common factor is the largest monomial that divides evenly to your polynomial. You're going to identify the GCF. That's always your first step when factoring. So looking at example 1. First step is to find the GCF, so we're looking at all three of them. Notice that they all have a 4 in common, and then also notice they all have an x. So our GCF is 4x. We're going to open parentheses, and remember when you do this, you divide all of them by that GCF. So 12x cubed divided by 4x would be 3x squared, and then plus 1x. And then plus 2. Once you have factored out that GCF, always check to see if you can continue on. Notice we have a trinomial, and the sum would be 1, and then the product would be 6. So there's not anything that adds to 1 that multiplies to 6, because you would have 1 times 6, 2 times 3, and none of those add to 1. So that's as far as we can go. So that would be our final answer. Okay, let's try another one. We'll go below it. So first step is to check for that GCF. Greatest number would be 6 between those two. And then notice there's an x cubed and an x squared. So x squared would be the smallest. So 6x squared would be the GCF. Open up parentheses. We're dividing each one of them by that. And we get x minus 7. Remember, if you distribute, it should give you back the original. So remember, when you're factoring, you're just writing it a different way. So always check the inside. We cannot factor x minus 7, so that's our final answer. Okay, looking at the next one, looking for a GCF. Greatest number that will go into all three is a 2, and then they all have a variable x. So GCF would be 2x. I'm going to divide each one of them by 2x to determine what's left. So that would be 3x squared plus 2x minus 4. Again, you need to check and see if you can factor the inside. Sum is the middle number, 2. Products the outside numbers, which would give you negative 12. So negative 1 times 12, negative 2 times 6, negative 3 times 4. None of those will add to positive 2. So that would be my final answer. So sometimes you can continue on, sometimes you can't. You need to check for that. All right, next part, we're going to look at quadratic form, which is very similar to factoring with ax squared plus bx plus c. So these you have three terms, which are trinomials. You're going to be using sum and product. First step, GCF, but notice they don't have anything in common, so we go straight into sum, which is the middle number, 3. Product are the outside numbers, which is negative 10. So that would be negative 2 and 5. You multiply, you get negative 10. You add, you get positive 3. So we need an x minus 2. For now, I'm just going to put an x, and then an x plus 5. Now, x times x isn't 2x to the 4th, so we're going to need to put squares on both of those. But then also, we need to take that 2, and we need to use the swing method. So I'm dividing each one of them by a 2. Next step is to reduce if possible. So 2 divided by 2 is 1, so that would be an x squared minus 1. And then we can't reduce this one, so swing it in front, 2x squared plus 5. Check after you factored, see if you can continue on. Notice we can right here. This is difference of squares. X plus 1, x minus 1 will multiply together to give us x squared minus 1, and then we can't factor 2x squared plus 5. So again, once you have factored, make sure you look to see if you can keep factoring. All right, number 3 here. So first step, GCF, they don't have anything. Sum is negative 6. Product, look, that's a 1 there, so the product's negative 27. So that would be 3 and negative 9. You multiply, you get negative 27. you add and get -6. If you can't do that in your head, write them out in order, 1 and 27, and then keep going. All right, so I have x plus 3, x minus 9. Notice this is an x to the 4th, so we need squares on those. And then we need to look at the front. That number is a 1. If we divide these by 1, we get the same exact thing. So you could always use the swing method, so that way you don't forget, but that's going to give us the same exact thing. Looking at it, we need to check for difference of squares. We are not subtracting here, so that cannot be factored. We are subtracting here, and 9 is a perfect square, so that would factor to x plus 3, x minus 3. And it doesn't matter the order that you write those. So make sure when you're factoring these, check for that difference of squares. You can only factor difference of 2 perfect squares. All right, last one for this section. So again, check for a GCF, but they don't have anything. Sum is the middle, -3. Product, that's a 1, so you get -28 for the product. So that would be 4 and -7. So I'm going to have an x plus 4, an x minus 7. Notice the first term is x to the 4th, so we need to put squares on the x's there. Check for difference of squares. We are not subtracting here, even though that is a 4 and it's a perfect square. We cannot factor x squared plus 4. If we put x plus 2 times x plus 2, that's going to give us x squared plus 4x plus 4, which is not the same thing. So I cannot factor this. This one is subtracting, but 7 is not a perfect square. So this is my final answer. Sometimes you can continue on, sometimes you can't. All right, the last one, our last section for today is grouping. So anytime I have 4 terms, I'm going to factor by grouping. So if you remember, first step is to check for a GCF of all 4 terms, which notice on this example, they do not all have something in common. So you group the first 2 and the second 2 together. We're grouping these 2 together. We're only going to find the GCF of those 2, which would be x squared. So that would be 3x minus 2. You always want to bring down your middle sign, so bring down the plus sign. Looking at the last 2 that you group, find a GCF. They don't have anything, but you have to put a number. If I take a 1 out, I get the same exact thing. If you remember when we were going over this before, remember these 2 have to match. If they don't match, then you messed up. We write that once, 3x minus 2. Then to get your other factor, you are grouping this part in front with this part in front. So x squared plus 1 would be your other factor. You check to see if you can continue on. We can't because that is sum of squares, not difference of squares. So this is our final answer. So make sure you don't leave it like this. That is not multiply together to give us that. So just make sure you finish out the factoring piece of it. Okay, the next one. So we need to check for GCF. They don't all 4 have something in common, so I'm going to group the first 2 together. GCF of those 2 would be 2x squared, which leaves you with 5x plus 2. Bring down your plus sign. GCF of those 2 would be 3, which would leave you with 5x plus 2. Again, these should match. If they don't, you did something wrong, so write that 5x plus 2 once, and then you're grouping together the piece that's in the front. So 2x squared plus 3. So make sure you're checking the squared piece. Make sure you can't factor it. We cannot factor that anymore, so that is our final answer. And just a reminder, checking factoring, you multiply these together using FOIL, combine your like terms, and it should give you back the original. All right, last one. First step, check to see if all 4 have anything in common, and they do not. So I'm going to group the first 2. GCF would be 3x squared, which would leave us with x plus 8. And then always bring down your middle sign. So I'm bringing down the negative, and they have a 7 in common, and you're going to be taking out a -7 because of that subtraction that you brought down. So negative 7x divided by negative 7 is just x. Negative 56 divided by negative 7 is a positive 8. Remember, these should match. They do. Write it once, and then group together the 3x squared minus 7. Check the squared one. You're subtracting, but 3 and 7 are not perfect squares, so that's as far as you can go. To check it, multiply it together using FOIL, combine your like terms. It should give you back your original. So this is a review of factoring. If you have any questions, please let me know.